What's up guys, this is Sabish Khan and in this video I will talk about a segment and different fields of the segment. So let's get started. Well, UDP, that is user datagram protocol, and TCP, that is transmission control protocol, are transport layer protocols. Okay, but before discussing what is segment, let us understand what is PDU. Well, PDU is the generic term and PDU is the protocol data unit that represents the unit of data that is specified by the protocol of the given layer. Well, for example, at data link layer, the unit of data is frame. At network layer, the unit of data is datagram, and at transport layer, the unit of data is segment, and so on. So, well, you can call this frame PDU, you can call this datagram PDU, and you can call this segment PDU. PDU is a generic term. Well, for example, if someone said that PDU of data link layer, it means frame. PDU of network layer, it means datagram. PDU of transport layer, it means segment. So in transport layer, when protocol is TCP, then the PDU is called segment, right? Well, so now this segment basically consists of header and data, and header has length from 20 to 60 bytes. If there is no option plus padding field, then the header length is 20 bytes. Okay, so this now let us talk about header. This is header of the segment, and it has fields such as source port address, destination port address, sequence numbers, acknowledgement numbers, header length, reserved bit, that is control field, which consists of urgent flag, acknowledgement flag, push flag, RST flag, sync flag, and fin flag. Then we have window size field, this then checksum field, and then urgent pointer field, and then we have options and padding. Now let us discuss them one by one. Okay, well, what is a source port address? Well, assume that this is client and this is the process that is running on this client, and this 2000 in the process port number. Similarly, I have a server, and there is a process that is running on this server, and the process port number is 80. So, well, if this client is sending something to this server, then this client is the source and this server is the destination. Okay, and and here as the this is as source port address is the address of the port number of the process that is running on the source, and so that's why here source is the client, and which is this one, and its source port address is 2000. Similarly, if this server is sending something to this client, then the server is the source and client is the destination, and in this case source port address will be 80, right? Number two, destination port address. Well, if this client is sending something to this server, then the client is the source and the server is the destination, and as the process that is running on this server is 80, so that's why the destination port address will be 80. And if this server is sending something to this client, then this server is the source and this client is the destination, and the port or the destination port address will be 2000. Okay. Then we have sequence number. Well, it is 32 bits field, and as TCP numbers every byte of data, sequence number is the number of the first byte of the data. Well, what does it mean? Well, assume that we have segment of 3 bytes, that is byte number 1, byte number 2, byte number 3, and we number them such as byte number 1 is 201, byte number 2 is 202, and byte number 3 is 203. As the sequence number is the number of the first byte of data, so you see that the number of the first byte, that is byte number 1, is 201. That's why sequence number is 201. Okay. Well, with the help of sequence number, destination knows that which byte is the first byte of the data coming from the source. For example, if this segment is received by the destination will know that the number of the first byte is 201, and 201 is the first byte, right? Then we have sequence number is the random number that is chosen by client or server. Okay, and in TCP during connection establishment phase, client and server chooses random number that is called ISN, which is initial sequence number, and it is self-explanatory, right? Well, then we have acknowledgement number. It is 32 bits field, and TCP uses acknowledgements to confirm the receipt of the segment. Okay, and it defines the byte number of the next byte that it expects from the sender. Okay. Similarly, in TCP, originally acknowledgement numbers are cumulative. So, what does it mean? Well, it means that for example, the you have sender and you have receiver, and the sender has sent three segments. One is a segment having sequence number 201, the other segment sequence number is 301, and the third segment sequence number is 401. Okay, and it is clear that each segment has 100 bytes. Okay. Well, so whenever this sender sends these segments, and now the receiver wants to acknowledge this segment, so you see that the acknowledgement number is 501. So it means that it is so whenever this acknowledgement is sent to this sender, so it means that his sender, I have received a segment having sequence number 201, a segment having sequence number 301, and segment having sequence number 401 successfully, and this receiver doesn't have to acknowledge every segment separately. Okay, and that's what do we mean by that acknowledgement number is cumulative, right? Because it's just using only one acknowledgement number to acknowledge all the three segments. Okay, that is sent by the sender. Now we have header length, that is Helen, right? So it is 4 bits field, right? And it indicates total length of the header, right? And header length can be between 20 and 60 bytes. If there is no option and padding field, header length is 20 bytes. Okay, scaling factor of 4 is multiplied to determine the length of the header. To understand this, well, for instance, if the header length value is 5, it means that total header length is 5 multiplied by 4, which is equal to 20. Similarly, if header length value is 15, it means that header length is equal to 15 multiplied by 4, which is equal to 60, and the scaling factor is 4. Okay, whatever the value of header length, you have to multiply it with the 4, and okay, to get the header length. Then we have reserved field, and it is 6 bits field, and it is reserved for use in the future. Okay, control field, it is 6 bits field, and this field basically defines 6 control flags or bits. We have urgent, acknowledgement, push, RST, fin, and sync and fin flag. Okay, you are urgent, which is urgent pointer is valid. When it is set to 1, it means that urgent pointer is valid, and it means that segment contains urgent data. Acknowledgement, that is acknowledgement is valid. When acknowledgement flag is set, it means that acknowledgement is valid. Push, which is equal to request for push, and if push flag is set, the sending TCP let the receiver receiving data that the segment, it will let the receiver, okay, it will let the receiving data that the segment includes the data that must be delivered to the receiving application program as soon as possible, right? Then we have RST, which is equal to reset the connection, and when the client or server process wants to deny connection or abort existing connection or may terminate an existing connection, the RST flag is set. Okay, sync, which is synchronized sequence number. Well, when sync flag is set, it means that the segment is sync segment and used during connection establishment. Then we have fin, which is equal to terminate the connection. When fin flag is set, it means that the segment is fin segment used during connection termination. Then we have next field, which is window size. Well, it is 16 bits field, and this is referred to as receiver window size, which is RWND, as it is determined by the receiver. Okay, so let's say that the receiver advertised the RWND size of 1000. It means that it is telling the sender that hey sender, you are sending window size must be let's say if RWND is 1000, then it is gonna tell the sender that hey sender, you are sending window size must be 1000 because I can just only accept 1000 byte. That's it. then the sender must obey receiver. Okay, and sender will choose window size that is chosen by receiver. Okay, field number 9, which is checksum. Well, it is 16 bits field and it is an error detection method, right? Checksum is calculated at center and the value obtained is sent with the segment. Okay, and the receiver repeats the same calculation on the whole segment including the checksum. Okay, if result is satisfactory, segment is accepted, otherwise it is rejected. Okay, number 10, we have urgent pointer, and this field is valid only when urgent flag is set, and this field is used when the segment contains urgent data. So thanks for watching.